Hello and welcome to Thursday's edition of Cracking the Cryptic, where I'm recording this in the middle of an electrical storm. There is a ferocious load of lightning going on. I hope that won't disturb the video. Could you see that? That was lightning. It's very unusual, actually. Whoa, and there's thunder. So, yeah, obviously the storm is quite close at the moment. Anyway, what better time to distract myself with some Sudoku solving? And that is what I plan to do with a puzzle called Rail Cars by Analytical Ninja. And I think this is Analytical Ninja's debut on the channel. And this one has been recommended to us a couple of times, actually, as being two things. Firstly, beautiful, which is great, and secondly, approachable, which is also great, especially after yesterday when I had to do battle with this. Archery Target by Nahileon, one of the great puzzles of all time for me. We called the video a masterpiece, not because of my solver haste, but because this puzzle is a masterpiece. It took me 1 hour and 37 minutes to solve it. And we actually released this as a premiere on the channel for the first time yesterday, which was very cool because it allowed us to sort of chat with you while the video was going on. So thanks so much to the some 2,000 of you who joined us during that video. It was great fun and yeah, delightful really to see so many kind comments. Yeah, and if you haven't had a go at that puzzle, I definitely recommend it, although I will tell you it is fairly difficult. Now, anything else to mention? I don't think there is much today. Oh, you've got until tomorrow, though, to get in your solutions for the May monthly reward. So tomorrow's the 20th, and that is the closing date. So if you want to be in with a chance of winning the prize, then you need to solve the equal sum line Sudoku hunt by tomorrow, which is very achievable, actually, because that is quite approachable. So if you haven't started yet, you've still got time to do it. And if you haven't joined us on Patreon yet, please consider it. We would appreciate it. The support over there keeps the channel going, and we're very grateful to everybody who supports us there, of course. Now, let's get on with the rules of Rail Cars. They are as follows. Normal Sudoku rules apply. Each line must contain a set of consecutive non-repeating digits in any order. So these are so-called Renban lines. So that means if we worked out this cell was a 1, then because we know that the digits on the line have to be consecutive, these would have to be 2, 3, 4, and 5 in some order, and that's how that line might work. For each line, digits on it have an equal sum n within each box it passes through. Right, so that's not how this... Well, it is how this line works in terms of the Renbanage, the consecutive digitsness, but it is not how it works in terms of this equal sum line rule. And there's an example here. It says, e.g., row 1 column 6 is equal to the sum of row 1 column 7 and row 2 column 7. Yeah, so that makes sense. So that's saying this cell is the sum of these two cells. And we can go further than that. If we look at this line's appearance in box 4 here is only in this cell. So that cell must be equal to the sum of those two cells, which are the two instances of this line in box 1, which must be equal to these two cells, which are the two instances of this line in box 2, etc. And that must apply for all of these lines. Hence why, when I made this a 1, that will not work as the lightning flashes again, because I can't make those two cells add up to 1 fairly self-evidently. Now, do have a go. The way to play is to click the link under the video, as usual. Now, I get to play. Let's get cracking. No given digits today. And okay, how long are these lines? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Okay, that's very interesting. 1, 2, 3, 4. Yes, that is very interesting. So that gives me a digit in the grid immediately. If you don't see that immediately, how to get a digit in the grid from this line, do pause the video and have a think, Agad Matus style. I'll give you a moment. If you got it, congratulations. The reason is we can think about the mathematics of this line, because we know that every time it enters a new box, it must have the same total. So we know those two cells add up to the same as these two cells, add up to the same as that cell, add up to the same as that cell, add up to the same as these two cells. Well, that means that because we know that every time there's a new colour, it's basically like x. So if we label the sum of the green cells as x, we know that x is the same as the yellow, x is the same as the red. So this line could be expressed algebraically as 5x. Now, do you know the secret? Now, the secret is very important in many Sudokus. The secret is that any complete row, any complete column, and any complete box of a Sudoku, because of the rules of Sudoku, they have the numbers 1 to 9 once each. And now the numbers 1 to 9 once each, if you add them up, you get 45. So because this line can't have a repeated digit on it, because of the rules of the puzzle, the numbers 1 to 9 appear on this line. So this line adds to 45. And 45 divided, if we know 5x equals 45, we know x equals 9. That's a single digit. So that's got to be, you've guessed it, a 9. And these dominoes each add up to 9. Oh yeah, they each add up to 9, and they're all different as well. We must remember that. Now, that line looks suspiciously symmetrical to this one, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So exactly the same is happening on this bottom line, which means this is a 9. And yes, and if we do our dominoes, let's do some dominoes along this line. We run out of the pretty colours, so we're going to have to use the more murky ones. Oh dear. Hang on. No, I really have run out unless I use light grey. Okay, so now we can ask where 9 goes in the middle box of the grid. Now, in theory, by Sudoku, it could be here or here. But if it was to be on one of the lines, it would repeat. And not only that, these two squares have to add up to 9, so that would have to be a 0. So this is for many reasons wrong, and that means 9 goes in the middle of the grid here. And now I'm wondering actually where 9 goes in this box, because again, 9 can't go in these dominoes, because they'd have to be 9, 0 dominoes, and they would repeat on the line again. So 9 is in one of those two cells. Now, does that work? Yes, that works this way as well. So 9 is in one of these two cells. And okay. Now, what I'm wondering is if the 9s are this way round, you can see these 9s basically form an X-wing in the sense that they're either on this limb of an X. If we draw a line between these 9s, they would correct with this slash, or they're on those two lines of an X, and they would be on this slash of an X. That's why it has the name X-wing. Now, if this is 9, now does that work with this? The answer is, I'm not sure. We would know that this domino would have to be the same as this domino, wouldn't it? Because this would have to add up to 9, and it couldn't be black, it couldn't be orange, and it couldn't be grey, because those digits are ruled out of this cell. So this would have to be sort of medium grey, and then these two cells would have to be purple by the looks of things. I can't see immediately why that fails. Yeah, sorry. There might be a reason that fails, but I'm not immediately seeing it, so I'm not going to rely on that. So, what else can we say about the world? Let me think about this. I feel like, actually, what we ought to be able to do is to merge our colours somehow here. Is that true? Is that true? Let me think about that. So what I'm wondering is, can I turn these drab colours into these colourful colours? But this obviously can't be yellow. but it could perhaps be green, blue or purple. Maybe I can't do that. Let me just think about that for a moment or two. No, alright. So what is it we're meant to do? I feel like I'm missing a trick, actually. If this was 9... Oh, you know what? I can disprove this. I've just seen how to do it. Right, rather than thinking about it the way I was, if this is a 9, what is the colour of those two digits? Well, if you think about the maths of this line, these two squares now have to add up to 9, because the whole row adds to 45. That domino adds to 9, that domino adds to 9, that domino adds up to 9, and that domino adds up to, well, that monomino adds up to 9. So these two squares add up to 9, and because we've used every digit apart from the purple pair, this would have to be the purple pair, but this cannot be purple. So that wouldn't work. Now, is that logic the same? I think it must be the same here. Yes, it is. It's exactly the same. It's analogous logic in this row. It's cute, actually. I should have spotted it quicker, but I didn't. So if this is 9, the point is both of those have to be this coloured grey, and this one couldn't be. So there we go. We could have got this before, and we just didn't spot it. And that's the royal we, of course. There we go. So now we've got a bit further. We've got more 9s in the grid. So can we do more 9-age? Yes, we can. Because you can't put a 9 on this, because then this would have to be a double-digit number, because it's the sum of those two. So 9 is in one of these two. 9, oh, no, 9 can't be here, because this is summing again to a single-digit total here. So 9 can be down there. Do we get the same thing? Ah, maybe not. Let me think about that. So can we rule out 9 going on this Renban? Now, if 9 is on this Renban contains 98765, which add up to... no, that doesn't work from Parity. Well, that's lovely, actually. Okay, so we can ask where 9 goes in this box, and I'm going to allege it's in these two cells, which means 9 up here is in these two cells. Now, let me revisit why this cannot have a 9 on it. Now, this line needs to be expressible algebraically as 2x, because those 3 digits must add up to x, and those 2 digits must add up to x. So the total of this line is 2x, which is an even number. Now, if we put 9 on here, there are 3 odd digits on here because of the Renban rules, because it would have to contain 9, 8, 7, 6, and 5. 9, 7, and 5 are all odd. That's 3 odd numbers in the total, which means the total for that Renban is odd, and that cannot be expressed as an even number. So that doesn't work, which moves the 9s here. I'm not actually sure how useful this is, because we don't seem to be able to actually rule 9 out of any of these places, but that's quite interesting about this line. So the same thing, that can't have a 1 on it for the same reason. Yeah, so it could obviously be something like 2, 3, 4, 5, 6, because that would add up to 20. Half of 20 is 10, and you could make that 2, 3, 5 and that 4, 6, for instance. So this one it's a little bit interesting. Right, okay, but the corollary of what we've done with the 9s here, it's the same logic we can apply in row 6, isn't it? This domino here, because you can't repeat a digit on these lines, this domino hasn't yet appeared in any of those 6 cells. And it must be somewhere in row 6, so it's got to be in those 2 cells. So those 2 squares are dark grey, and by the same token, those 2 squares are purple. That might be helpful. Well, right, there's all sorts going on here now. This is this is suddenly getting very interesting. Oh, there must be some... Right, I can't quite figure out the middle box yet. I think there's something going on there, but I can't see how to recolour this. But what I have noticed is this digit is suddenly interesting, especially in the context of these two cells, because we know these two cells add up to 9, but this is the single digit total, which is adding up to a double digit total. Well, not this is these two digits are adding up to this. So if we think about the ways of adding up to 9, you're going to have a small digit like a 1, 2, 3 or a 4 always pairing up with a 5, 6, 7 or an 8 on the other side. Well, this cannot be the 1, 2, 3 or 4, can it? Because then this will be the 5, 6, 7 or 8, and we'll be adding numbers here that definitely are greater than this. So I think that the way round this is that's 1, 2, 3, 4, this is 5, 6, 7, 8. Which might matter somehow, some way. Wow, can you hear that start? That's really, really bad. Okay. So, how do we take that forward? Let me think about this. Right, yes. No, no, actually. Oh, yeah. No, this is good. Right, where does this digit live in this box? That's the question I want to ask, I think. Because clearly it's not in these cells by Sudoku. It's not a 9 by its nature. And it can't go here, because then it would repeat on its Renban line. So, it's not in any of those cells. Now, could it be in the purple cell? Well, no, it couldn't, because purple is looking at it already. So it's not purple. And could it be in a yellow cell? No, because if it's in a yellow cell, its partner, which is this digit, must also be in this yellow domino. So this digit is exactly there. This is really actually a lovely puzzle so far. It's very interesting. Now, this means we know the colour of dark grey, of this grey, I think. Let's ask what it can be. Whoa. Well, it's definitely not purple, so we know that. So what I'm trying to do is to analyse it in terms of the colours of this line. Well, it's not purple, because purple looks at it. It's not yellow, because yellow is in a box with it. Now, is it blue? No, because blue sees those two cells there, so it can't be blue. So in fact, it must be green. So those two, this and this, can all now be changed. Oh, bobbins. That's a mistake. I didn't want to get rid of the... I only wanted to get rid of the colours. Sorry, I want to make them all green. Now, can I then extend that logic a bit further? Do I now know what this domino is? Does that mean this has to be blue? Maybe. Let's just think about this. So the possible colours of this domino, in terms of the colouring of the top, this line, are, it's not yellow, it can't be purple, it sees a purple, and it can't be green, yeah, so that's blue. So this is all becomes blue. And now, okay, so now this colour, which needs to be a colour, doesn't it? I know it needs to be a colour, that's slightly fatuous. But it's not blue, it sees blue. Oh, this could be, it can't be purple, so it must be yellow, because it's not green. Right, that's yellow. And we're left with this colour. Hopefully this can be something. That has to be purple. That's the only thing it can be. That's really lovely. So now we've managed to unify, we found the unified theory of colour here. And we've coloured both lines completely with the same colour scheme, which we hadn't achieved before. And that tells us this cell is purple of all things. And that might matter for some reason I haven't got a clue about. What is that reason? Okay, so that's got to be the high. Oh, has it actually? No, that might be wrong. I was about to allege something about the size of this digit, but I don't think that's good logic. Well, okay, this cell has to be the sum of 2 digits here and the sum of 2 digits here. Now, that means that there have to be 2 different ways of making this total. So if this was a low number, if this was a 4, say, well, this could be 1, 3, but then this would have to be 1, 3 as well. So that means this purple digit is the high version of the purple digit, which means this is the low version of purple, which means this is the high version of purple. So now we know the minimum sum of this is 6, which means this can't be 5. Which means this can't be 4, because we know green together adds up to whatchamacallit, adds up to 9. And do we know anything else? That's the next question. So we know this cell now is not 5. But so if this was 6, this would be 3, and that would be 3. Hang on, that's nonsense. What am have I gone totally wrong here? I think I might have, I'm almost thinking I've gone wrong here. 5 and 1 can be 6 in theory. Oh, sorry, yeah, hang on. No, this is weird. So if this is 6, because that has to be 3, yeah, there's all sorts of combos here. So although the maths works, what we've got to remember is there is a relationship between these 2 green numbers, and that's what I'm forgetting. Okay, so because these add up to 9, if that is 6, this has to be 3, and then that has to be 3, and that clearly is impossible. So this is not 6. So that means this is not 3. Now, if this is 7, that has to be 2, and that has to be 5. And that would be 4, and that actually might work. And if this is 8, this is 1. No, that doesn't work. Oh no, that would be 7 then. That does work, sorry. 8, 1, 7. No. This is lovely. Wow, Analytical Ninja. This is a beautiful puzzle. Right, that is not 8. And the reason this is not 8 is then on the same Renban line, which is not long enough, it's only 7 cells long, I've got the digits 1 and 8, and that can't work, can it? Am I going mad? 1, 2, 3, 4, 5, 6, 7. No, of course it can't work. So, if this is 8 and this is 1, this Renban line cannot be full of consecutive digits. So that has to be 7. That has to be 2. Therefore, this has to be 5. This has to be 4. This has to be 5. This has to be 7. This is a 2-7 pair. So these digits now are 1s, 3s, 6s and 8s. And the same must be true of this and this. 1, 3, 6, 8. That's 4, 5. The same as its friends here. And this is 4, 5 by purpling. And let's get rid of the redness of the 9. I don't think we need to redden our 9s. And now we can pause and think about what we've learned. Right. Yes, remember, this is a consecutive sequence. So these have to be 3, 4 and 1, 6 in some order, because we're always trying to add up to 7. 1, 3. So that's not 4, so that's not 3. and bobbins. That seems to just die a death there, doesn't it? It doesn't seem to go any further. But that means the remainder of this row... Oh, hang on, we know what these two digits are. These are 2 and 7. So the remainder of this row is now 2, 5, 7 and 8. So these digits are 2, 5, 7 and 8. And that is not 7 or 5. So this is 2. Oh, nearly, look. Nearly. Now, right, can we do something using the parity of this then? 8, 7, 6, 8, 7, 6, 5, 4, 15. Yeah, right, this is lovely. Wow. I'm going to allege that this cell is not an 8. Because if it's an 8, look, you can't put 9 on its line. So you know it's the sequence of digits 8, 7, 6, 5, 4, which add up, I think, to 30. Now, if this line adds up to 30, because it's expressible as 2x, this sum is the same as this sum, this would have to add up to 15, but I can't use the 8 again. So that I can't. So the highest these digits could be would be 7 and 6, and that doesn't add up to 15. So that cannot be 8 because of the weird nature of this rule. And that still doesn't actually get me there, though, does it? Well, it might. Oh, this is yeah. No, this is quality. This is quality. Although I still don't think it gets me there. The same reason it can't be 7 actually, and it can't be 7 because if there's an 8 on this line, this would have to add up to 15, and it can't because the 7's not available. And if it's 76543, it's got 3 odd numbers on it, and it cannot be expressed as an even digit. So it's got to not be 7. And look, I'm still no closer. So, oh, no. No, I am closer, because it can't be 2, so it's 5. Oh, this is lovely. Right. So it's got 5 on it. That's not surprising. It's a 5-cell Renban. It must have a 5 on it. I could have filled that in at the very start and no one could have denied it. There's not a 5 up there. Oh, look, this is 5. So this is 1, 2, 3, 4. That might be helpful. Well, that's not 2, so that's not 3. Yes, that cell's a 5. And that's a 4. Which does absolutely diddly squat, I think. So the remainder of this row is 6, 7 and 8. That's not 7. Oh, of course, look, why am I being so slow? 2, 7 there means this is an 8. That's a 2. This isn't 8 anymore, so this isn't 1. And okay, probably I can do better than that somehow. Problem is this thing can poke out down here. So I don't think I really know what's on it yet. Yeah, that's weird actually. So I was bemoaning its ability to have 8s and 7s in this position. But it could be a 5, 6, 7, 8 line now with a 5 here, because you could put the 7, 8 there and that would work. This would be 5, 6 and 4. But if it's not that, so if it's not 8, 7, it would have to be 6, 5, 4, 3, 2, wouldn't it? Now 6, 5, 4, 3, 2 is... this is... Alright, quality. Analytical ninja, this is beautiful. Right, so let's think about the nature of this 5-cell line. Because of this trick regarding odd numbers, and it can't have a 1 or a 9 on it, in fact, this line is selectable only from 7 digits. So it's either 2, 3, 4, 5, 6. That's one thing it could be. It can never start with a 3. or it's 4, 5, 6, 7, 8. There are only 2 possible variations, because it can't start with a 3 and it can't start with a 7, or it's got 3 odd numbers on it. Now, if this was 2, 3, 4, 5, 6, 2, 3, 4, 5, 6 add up to 20, which means our magic number is 10 here. This would be 10 and this would be 10. But for that to be the case, this would have to be 2, 3, 5, and it can't be. So this is 4, 5, 6, 7, 8, with the 7, 8 here. And this is, therefore, 4 and 6, which means that's not a 6, which means this is not a 3. And that is not a 4, and this is not a 1. And now, I must do something more than that, surely. Oh, come on. Those 3 digits are 1, 3 and 9, and that's not a 9. So that's very, very useless. Good grief. Okay. 2 of these are blue, I can tell you that, but I don't think I can do any more than that. 4, 5. 2 has to be in one of these cells. That's totally useless. I've only got that line to use, and I'm pretty certain that line is not helpful. This line has to add up to, well, it has to have 2 odd digits on it, doesn't it, this one? Because if it had one, if it was 2, 3, 4, it would sum to an odd number, and we'd have exactly the same problem we have here. So this could be 1, 2, 3. Simple as that. Could be 3 and a 1, 2 pair. Now, if it's not that, it's got to have 2 odd numbers on it. So 3, 4, 5 would not. Oh, for goodness sake. Oh, that's really clever, actually. Oh my goodness. This line is 1, 2, 3. It didn't even occur to me this was under pressure. But because it's a Renban, and it's got to have 2 odd digits on it, anything bigger than 3, 1, 2, the sum will never work. Because obviously if this was 3, 4, 5, you can put the 5 in the biggest where it has to be, but the 3 and the 4 don't add up to 5. And that's going to be the same for any combination we use here. If we go 5, 6, 7 and put the 7 here, it won't work. So this is 3 with a 1, 2 pair. And that's probably what we needed to figure out much, much earlier. It didn't even occur to me that that was going to be. Ah, this is it. Right, look at this. Look at what this is doing. This is not a 3, 4 pair now. So this is 1, 6, which means this is a 3, 4 pair. This is 1, 6. Oh, this 2. How did I get this 2? Because that seems to be doing something here. Why is this a 2? I don't trust that at all. What was this before? It was a 2. Oh, it was a 2 or an 8. So getting this 8 gave me. Okay. Yeah, and I just didn't follow through on the Sudoku. Okay, I can believe that. No comments, thank you. Okay, so what does that mean? Have we now figured out the world? Or are we still struggling? These are 9s, aren't they? These ones are 7s. This is not a 1, so that's not an 8. And there's a 7 in one of those 2 cells. There's a 7 in one of these 2 cells by Sudoku. Don't think we know where 8 goes in this box. That's strange as well, because now, 3 in this box has to be in this domino, which means that's not a 3. Is that useful? Perhaps. Although I'm not seeing how. I'm now missing something else, aren't I? But there's no more clues to use. So there must be some Sudoku trickery we can do here. to try. Oh yeah, there we go. Sudoku trickery. Where does 3 go in that column? That's what we needed to spot. Look, can't go there, can't go there, so goes there. And that is massive because that's going to finally disambiguate the nature of blue. So blue is not 3, 6, so it must be 1, 8. And look at that. There's only one way round that goes. So that's 1, that's 8, that's not 8. And does that do it? So this is now 1, 8, which probably is useful, which means this is 6 and this is 3. This is now a 3, 6 pair. Let's put that in. This 3 is, oh yeah, this 3 was useful here, look. It's disambiguating this line. This is a 1, 4. Gosh, I've missed all sorts of things in this puzzle, but I've still enjoyed it mightily, I have to say. Look, this 2, 3 is done now. 3, 2, 2, 7. So look, there's a 5, 7 pair at the top of column 2, which doesn't actually seem to be resolved by anything. But now we can do no, 3 gets hidden in the corner, and that's 3 in the corner. That's 3 in the spotlight, losing its religion. That cell is a 4 of all things. Now 4 is the colour of purple, and these need to be a 1, 8 pair, which is of course the blue digits. So maybe we'll try and do the colouring in the middle rows just to keep our colouring sane. Okay. Look, yeah, 1's in these. There's a little X-wing of 1's there. So that means we can ask where the 1 goes in this column. It can't be in those 6 cells, so it's got to be in one of these 3 cells, but it's also got to be in one of these 2 cells. So it's the only cell that meets both of those criteria is this one. So that gets us the 1, 4 pair. 4 by Sudoku has to go here, which displaces a pencil mark 3, which gives us the 3 and the 6 at the top. That gives us the 6 and the 1, and the 1 and the 8, which gives us the 8 and the 7. Now these 2 squares have got to be 2 and 5, which is not resolved. And we need 6, 7 and 8, so that's an 8. And this is a little 6, 7 pair of all things, which is not resolved. But now these 2, oh no, hang on, what's this then? Oh, bobbins. This is 1, 8, 9, isn't it? Up here. And that's not 8 because of this. That's still not resolved. Okay, what are those 2 digits? They've got to be 2's and 6's, and we can do that, which makes this a 7. And I'm sure this is resolved somehow. Right, let's have a look at this column. We need 1, 6's and 8's in there. 1, 6, 8. Now what can we get rid of? We can get rid of 1 from this square. That gives us a 6, 8 pair, which means these 2 squares are a 3, 9, and we can place the 3 and the 9. We've got a 1, 8 pair here. That gives us the 9 finally over that side of the grid. And down here we can get rid of 8 from this cell, but nothing, I think, from this cell. 4, 6 is done down here. Still got 1, 6, 8 left. Alright, what are those 2 squares? 2 and 5. Yes, that's resolved. Good. 2 and 5 get put in. I can't believe these aren't resolved, but they don't seem to be. Right, let's go back over here and see if we can see something else. This has the feel of arch dominoage, doesn't it? These sorts of dominoes annoying us in the top 2 rows of the puzzle. Have we used all the clues? I think we have. Oh no, 3, 4 is done here by Sudoku. Goodness me. Never do Sudoku in a storm. It really messes up with you. It messes your scanning up. 5, 9, 7 go in. 9, 1 go in. 1, oh, hang on. No, that's 8. Look, that's 6. That's 1. Therefore, that cell should be a right in. That's a 6. That's an 8. That's a 6. And finally, we can say... what? What's this done? Ah, yeah, it has done stuff. 6, 7, 7, 5, 5, 2, 2, 1. That gets us the 8 here. The 8 and the 1 go in, and we just need 1 and 4. And that can be done in this order, and we can click tick, and that's how to solve the puzzle. That's beautiful. What a lovely, lovely Sudoku. Rail Cars by Analytical Ninja. That is some debut. I really like that very much. Very simple setup in theory, but there was a lot of what I just describe as interesting logic to find in that puzzle. Really, really good, and a great distraction from the storm, which now seems to have gone away, and the house is still standing, and that is marvellous. So, thanks for watching. I look forward to the comments, especially if they're kind, and we'll be back later with another edition of Cracking the Cryptic.